concept that every student have to learn here. You know that for sin x, okay, for sin x, the domain, okay, the domain and the range like this. If you take the domain is a set of all real numbers and the range become -1 to 1 like this, right? That means if you have f of x is equal to sin x, x belongs to R and sin x belongs to -1 to 1 like this, -1 to 1 like this. Now, and within this it is a bisection, therefore here simultaneously its inverse function is defined. Okay, sine inverse x, here the sine inverse x, you know that range become domain and domain become range, and this for this domain, what is the domain? You are going to have -1 to 1 and the range, okay, for this what we are going to have is within -1 to 1 the range is become -pi/2 to pi/2. If you take okay, if you take -1 to 1 and the range you will be getting it as -pi/2 to pi/2 like that, right? Therefore here we have to understand one simple thing where it becomes a bisection like this. Okay, the sin x function where it is a bisection. If it is a bisection, then inverse is possible. Where it is a bisection means now -pi/2 to pi/2 it is a bisection, and even 3pi/2 to 5pi/2 also it is a bisection. But we are taking one primary thing. This is what the standard things, their functions, their domains and ranges where they are bisection, and inverse is possible where the inverse is possible such that what is their domain and range, right? Now we have here cos x. The second function is cos x. The domain where we are taking is 0 to pi and the range is nothing but, see, this is closed interval -1 to 1. Here also -1 to 1 like this, -1 to 1. Now for cos x, where it is bisection means 0 to pi it is bisection and the range become -1 to 1. Therefore, since it is a bisection, cos inverse x is defined. Okay, the domain of this is nothing but -1 to 1 and the range for this is 0 to pi. Within this thing it is bisective and inverse is possible. Now the third one what we have here, tan x. Tan x, okay, fine. The domain is -pi/2 to pi/2. Okay, so range is nothing but -infinity to +infinity, right? In this function, in this domain and range, it is bisective function, 1, 1 and on to. That's why inverse is possible, and its inverse now, tan inverse x is nothing but it takes from -infinity to infinity. Next, the range is nothing but what we have here, -pi/2 to pi/2 like this, right? These are the three things very, very important such that, right? Even number 4, cot x, where it is, okay, bisective function like some 0 to pi, and also this is from -infinity to infinity. Therefore, cot inverse x is defined here like -infinity to infinity and 0 to pi like this, right? Now the fifth one, cosecant x, where it is bisective function means -pi/2 to pi/2 except 0, because cosecant 0 is undefined. That's why. And the range become r minus of -1 to 1. In this now, cosecant inverse x is equal to, what we will be having is r minus of -1 to 1 to -pi/2 to pi/2 except 0 like this. Except 0 it is defined like this. Number 6, secant x, right? Secant x, where it is defined, where it is bisective means 0 to pi except to pi/2 like this, except to pi/2, and the range is nothing but r minus of -1 to 1 like this. Here also see, except -1 to 1 from the real numbers it is whose output values will be like this. Then in this it is bisective, therefore secant inverse x also, okay, this is from r minus of -1 to 1 to, okay, the domain becomes this and the range becomes, the range is now 0 to pi except pi/2 like this. This fundamental knowledge is required Okay, every function and its inverse is defined, because in these domains and ranges only, in this domain only, it is bijective function. That's why their inverses are defined. And whenever we do the problems, we are going to take these particular domains. And hi, welcome my dear students. We are going to do in this video different kinds of problems, right? On part of this, the first one, domain of log 1 by log mod x is equal to what? This is what our first problem. See here, now we know that log x is defined when x is greater than 0, right? Now here it is given that 1 by log of mod x. This mod x is actually it is in the denominator. It should not be 0. That means log, this cannot be log 1 is 0. It cannot be 0 like that. Therefore x is not equal to minus 1 and 1 like this. X is not equal to minus 1 and 1, and x should not be 0 also, because logarithms are not defined for 0. And since it is in the denominator, this value should not be 0. Therefore log of, since mod x we are having, x should not be equal to minus 1 and 1. Therefore the domain of this is nothing but what we are having. The domain is r minus of 0, 1, minus 1. This is what the total domain of this given function, like this. F of x is equal to, right, what we have here is r minus of 0, 1, minus 1 is the domain of this particular function, right? Here now we have another problem. The domain of f of x equal to cubed root of x into cot x, right? And here you see cubed root of x. The domain of cubed root of x is any real number, no doubt in it. And now we require to find the domain of cot x. The domain of cot x is very simple. You know that r minus of n pi, like this. R minus of n pi, where n belongs to z. We know that because cot x is not defined at, because cot x become cos x by sin x, sin 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi. At those values it is not defined. That's why the domain is nothing but, the domain of this is nothing but r minus n pi, like this, where n belongs to z, like this. R minus n pi, where n belongs to z. This is what the domain of f of x equal to cubed root of x into cot x, right? Here, the third problem we have, find the domain of f of x is equal to square root of log of 1 by modulus of sin x. This is equal to what we have here is, right, we know that square root we are having here, that should be greater than or equal to 0. That means log of 1 by mod sin x has to be greater than or equal to 0. That is possible when means, and this is actually log 1 is 0, no problem here. And modulus of sin x, this should not be 0, of course. This sin x should not be 0. Okay, because log 1 by that become undefined. Therefore where sin x is not 0 means x should not be is equal to n pi, where n belongs to z. Therefore the domain is nothing but r minus, the domain of this function is nothing but r minus of n pi, where n belongs to z, like this. R minus n pi, where n belongs to z, like this. Here now we have the fourth problem. Find the domain of f of x equal to square root of x square minus 4 times of mod x plus 3. Right? How we are going to do this particular problem is, right, we have here this is under the square root, therefore x square minus 4 times of mod x plus 3 greater than or equal to 0, right? Right, here x square, even we can write it as mod x whole square minus 4 times of mod x plus 3 is greater than or equal to 0. If you take a is equal to mod x, you have here a square minus 4a plus 3 is greater than or equal to 0, like this. Now this is equal to a square minus 3a multiplied means 3a square, adding means this minus 4a plus 3 is greater than or equal to 0 we have here. Now if you take a common, a minus 3 minus 1, if you take common, a minus 3 is greater than or equal to 0. Now a minus 3 into a minus 1 is greater than or equal to 0, like this. Right, a minus 3 into a minus 1 is greater than or equal to 0. That means we have here, yeah, if you take the real number line like this, 1 and 3, okay, greater than or equal to 0 here. In this part it is greater than 0, it is less than 0, here it is greater than 0. This is now minus infinity to plus infinity. We are having like this, right? That means you see here a is less than 1 and okay, and we have here r a is greater than 3 like this. These are the two things we have. A means what we have taken mod x. Mod x has to be less than 1 or mod x has to be greater than 3 like this. Greater than or equal to, even here we have here like this. This means x belongs to, you know that, minus 1 to 1 including this. And here you have here x belongs to minus infinity to 3 union 3 to infinity like this. Therefore x belongs to what will be the domain, means we have here minus infinity to minus 3, right, union 3 to infinity union minus 1 to 1 like this. This is what the domain of f of x, where x belongs to like this. Now we have this fifth question. Find the domain of f of x equal to square root of 1 by mod cos x like this. Therefore, you see here this has to be, first of all, we know it should be equal to 0, no problem, greater than or equal to 0, that's fine. And but it should not be, the denominator should not be 0, okay, because 1 by 0 that is not defined. Therefore, the denominator should not be 0. Therefore, x is not equal to, when the denominator cos x becomes 0, when it is odd multiples of 90 degrees. That means x should not be equal to 2n plus 1 into pi by 2, where n belongs to z like this. Right? X should not be equal to this one, 2n plus 1 into pi by 2. Therefore, the domain of this particular function is nothing but r minus of 2n plus 1 into pi by 2, okay, where n belongs to z like this. This is what the domain of this particular function, right? Here now we have this problem. Find the domain and range of f of x equal to 1 by 1 plus x square. Here the domain, you know that the domain, this should not be 0, of course, and x square is a positive quantity. This quantity will never be 0, as you have denominator 1 plus x square. This is always greater than 0. Therefore, for any x, for all x belongs to R, 1 plus x square is greater than 0. Therefore, okay, the domain of this function like this, the domain of f of x is nothing but set of all real numbers like this. Right, now let us consider the range. Okay, the range. Suppose if you take, while finding range, x is tends to infinity, this become what, 1 by infinity. 1 by infinity will become 0 like this. Right, and what is the maximum value of that? When x is 0 like this, when x tends to 0, that become what, 1 by 1 plus 0, that become 1. Therefore, the range you are going to have, right, fine, 0 to 1 like this, right? This is infinity. X will never equal to infinity. Therefore, the range is nothing but the range of this function. Like the range of this is nothing but what you will have is open interval 0 and closed interval 1 like this. The range is nothing but the open interval 0 and the closed interval 1 like. Now we have the seventh problem. Find the domain and range of f of x is equal to cos x plus sin x. Right, because cos x and sin x, whose domain is set of all real numbers, therefore obviously the domain of the domain of f of x is equal to set of all real numbers we are going to have. While we are taking the range, you know that we know that a cos x plus b sin x, right, will always lie between minus root over a square plus b square, okay, and root over a square plus b square. This is what minimum value, that is what the maximum value. Therefore, you have here now cos x plus sin x like this. This is lesser than or equal to root over 1 square plus 1 square, and this equal to minus root over 1 square plus 1 square. This is now minus root 2 lesser than or equal to cos x plus sin x is lesser than or equal to root 2. Therefore, the range is nothing but range of this function. This is nothing but minus root 2 like this, right? The range of this function is nothing but minus root 2 comma root 2, right? Like this, this wonderful problem can be done. Find this problem, find the domain of f of x equal to root over 3 minus x plus sine inverse of 3 minus 2x by 5. Let us take our function f of x is equal to f1x plus f2x, like this, right? Where f1x is nothing but f1x is nothing but root over 3 minus x, and f2x is nothing but sine inverse of 3 minus 2x by 5, like this, right? f1x equal to root over 3 minus x and f2x equal to sine inverse of 3 minus 2x by 5. Let us find domain of these both functions, and we have to take the common part of it. Like now, domain of f1x, like this, domain of f1x equal to, this is what root over 3 minus x we have here. Now this is 3 minus x has to be greater than or equal to 0. That means 3 is greater than or equal to x. That means x is lesser than or equal to 3. That implies x belongs to minus infinity comma 3, like this, right? The domain of the first function we have got very nicely, minus infinity comma 3, right? In the same way, let us find, see how we did very nicely. We have got 3 minus x greater than or equal to 0, 3 greater than or equal to x, and x is lesser than or equal to 3. That means x belongs to minus infinity to 3. Now let us find domain of f2x, like this. f2x, this is nothing but, we have here sine inverse of actually 3 minus 2x by 5, like this, right? How we are going to do this particular problem, let us observe here. See, now we have this sine inverse of x, as I told you, that minus 1 lesser than equal to x lesser than equal to 1. Now this thing we have here, 3 minus 2x by 5, this total thing should lie between minus 1 and 1, like this, because sine inverse x whose domain will lie between minus 1 and 1, like this. Now let us find the x value. If this lies between minus 1 and 1, okay, I just multiply by 5, then I will have minus 5 lesser than or equal to 3 minus 2x lesser than or equal to 5. Now I just subtract 3 on both sides because I want x value. Okay, then minus 5 minus 3, okay, here 3 minus 2x minus 3 lesser than or equal to 5 minus 3, that is 2. Now this is minus 8 lesser than or equal to minus 2x lesser than or equal to 2. You divide by 2. Now minus 8 by 2 lesser than or equal to minus x lesser than or equal to 2 by 2. That means minus 4 lesser than or equal to minus x lesser than or equal to 1. Now you just multiply by minus sign. Then what you will be having here, this is now 4 greater than or equal to x greater than or equal to minus 1. That means x is lesser than or equal to 4 and x is greater than or equal to minus 1, like this. Therefore now the common thing we need to take here, of course. In the first one I told we have got minus infinity to 3, first one. Here we are having 3. And x is lesser than or equal to 4. 4 is another common point, and minus 1. Now the first solution is what? Minus infinity to 3, right? 3 is included, like this. That's why it is shaded. Next, x is lesser than or equal to 4. X is lesser than or equal to 4. This is what the solution. Now x is greater than or equal to minus 1. Then you see here, we have here like this. Greater than or equal to minus 1. Therefore, now the common solution is where the 3 lines are present, like this. This is what the common solution. Therefore, x belongs to minus 1 comma 3, like this. Therefore, this is what the domain, very beautifully we will be getting this problem like this, right? Now this problem, 1 minus log to the base x square minus 5x plus 6 to the base 10 is greater than 0. That means 1 is greater than log to the base 10 x square minus 5x plus 6. Now log to the base 10 x square minus 5x plus 6 is less than 1. Right? 1 is nothing but log 10 to the base 10. Right? Like this we can write. Now this is x square minus 5x plus 6 is less than 10, like this. This is now x square minus 5x plus 6 minus 10 less than 0. Now x square minus 5x minus 4 less than 0. Now let us find its roots by formula method. We will get them. 5 plus or minus root 41 by 2. And it is less than 0. We are going to have the roots between. One is 5 minus root 41 by 2 and another one 5 plus root 41 by 2. Between these things we are going. That's why I have written here like this. And another condition we have here, log to the base 10 x square minus 5x plus 6 is there. That x square minus 5x plus 6 has to be greater than 0. Now this is greater than 0 means x square minus 3x minus 2x plus 6 is greater than 0. Now if you take x common, this become x minus 3, minus 2 if you take common, x minus 3. Now x minus 2 into x minus 3 greater than 0. Therefore 2 and 3 are the things you have here like this. Now x less than 2 means this, and x greater than 3 means this. Now the common area, okay, this is what the solution set we have here. Therefore x belongs to 5 minus root 41 by 2 comma 2 like this. This union 3 2, right? 3 comma 5 plus root 41 by 2. This is what the solution set of this, right? This is what the domain we are going to have for this problem, right? Now we have here find the domain of f of x equal to root over sine x plus square root of 16 minus x square. This, how we are going to do this particular problem, right? We have here, this is also we can write as f of x equal to f1x plus f2x like this. And where f1x, okay, yeah, is equal to, you know that f1x is nothing but root over sine x like this. And f2x is nothing but square root of 16 minus x square, right? f1x and f2x are this here, of course. Now f1x is equal to, okay, root over sine x we have here. That means we need to get sine x has to be greater than or equal to 0. Sine x has to be greater than or equal to 0. This is what we need to get, of course. And f2x we have here root over 16 minus x square. That means 16 minus x square greater than or equal to 0. That means x square minus 16 lesser than or equal to 0. That means x minus 4 into x plus 4 is lesser than or equal to 0. That means it is lying between minus 4 and 4 like this. Therefore x belongs to closed interval minus 4 comma 4 like this, right? Fine. Now sine x is greater than or equal to 0. When sine x will be greater than or equal to 0? Actually we know that in first and second quadrant x belongs to, right? You are going to have, where in first and second quadrant you are going to have, it will be positive. Here in our problem it is given that x lies between 0 to pi. Okay, in 0 to pi in first quadrant and second quadrant sine x is positive. That's very nice. Now let us try to get the common solution of this. This is what the real number line we are having here, minus infinity to plus infinity. Here we have here minus 4 and this is 4. This is 0, this is pi, like this we have here. Minus 4 to 4 like this. This is what, minus 4 to 4, and 0 to pi is this, of course. 0 to pi. Now the common solution is this part we have here. 0 to pi will be the common solution of this, of course. Therefore x belongs to 0 to pi is the common solution, and which is the domain of this, such that we will have for this function this one and this one is satisfied, and this is what the solution set of that. Like this we'll be doing whenever we are having like two functions. We will find each one domain and we take the common part. Here the common part is 0 to pi like this. Now we have this 11th problem. Find the domain of f of x is equal to cos inverse of 2 by 2 plus sin x. Here this problem, you see my dear students, you know that cos inverse of x, right? Cos inverse of x. When we take this one, x will lie between minus 1 and 1 like this, right? Therefore here we have inside this, in the place of x, we have 2 by 2 plus sin x. That is lesser than or equal to 1. It lies between minus 1 and 1. That's why we have here minus 1 lesser than or equal to 2 by 2 plus sin x lesser than or equal to 1. Right. Now we need to get x value. For that what we are doing is, we are having 2 by 2 plus sin x. Therefore I will divide by 2. Then it becomes minus 1 by 2 lesser than or equal to 1 by 2 plus sin x lesser than or equal to 1 by 2. Now I take inverse, okay, reciprocal of it. Then it become minus 2, and this lesser than or equal to will become greater than or equal to 2 plus sin x greater than or equal to 2. Now minus we need sin x. Now you subtract 2, then minus 4 greater than or equal to sin x greater than or equal to 0. Therefore, here this is now sin x greater than or equal to 0 and sin x is lesser than or equal to minus 4. Sin x is lesser than or equal to minus 4 is meaningless, and we have here sin x is greater than or equal to 0. Then the solution set when x is greater than or equal to 0 means when x belongs to 2n pi to the interval 2n plus 1 pi, like this. In this interval where n belongs to z, we are going to have x, okay, such that this inequality is satisfied and the domain is nothing but 2n pi to 2n plus 1 pi. Like this beautiful problem can be answered. We have some important concept that every student have. Now, the range of this function f of x equal to x square plus 1 by 1 plus x square is what? You know that x square range, you know, it is always greater than 0, like this, right? That means x square belongs to 0 to infinity, like this, closed interval 0 to infinity. Now 1 by 1 plus x square if you take, right, 1 by 1 plus x square, right, this will be, what will be the range of this? For the same x, what we are having is, this is also right, the value will be what we are going to have, that this belongs to 1 to infinity, like this, right? Even 1 by infinity, even 0 to infinity also possible, like this. When you take combinedly for the same x, now for the same x, when you have x is 0, like when x is 0, the minimum value, this is now minimum value is 1 and the maximum value will be infinity. Therefore, the range is nothing but like this. However, when x is 0, you are going to have 1, the minimum value is 1 and the maximum value become infinity. Therefore, the range is nothing but, range is equal to 1 to infinity, like this, right? The range of the function f of x equal to x square by x power 4 plus 1 is what? Here, when you take x square by x power 4 plus 1, when x is 0, right, it becomes 0. When you take x as any number, like here there is no possibility of getting this x square by x power 4 plus 1 is greater than or equal to 0. When x is 0, it becomes 0. And as x proceeds for any value, it leads towards infinity. Therefore, it will be 0 to infinity, like this. Therefore, the range is nothing but, the range is equal to closed interval 0 to infinity, like this, right? See here, the domain of f of x equal to sine inverse of x minus 3 by 2. This particular problem, as already I told you that sine inverse of x, when x lies between minus 1 and 1. Here x minus 3 by 2 supposed to lie between minus 1 and 1. Now we need x values for that, right? That means I multiply by 2, then minus 2 lesser than or equal to x minus 3. Okay, because 2 and 2 cancels and lesser than or equal to 2. Now add 3 to this. Now 3 minus 2 lesser than or equal to x lesser than or equal to 5, like equal. Now this is 3 minus 2, 1 lesser than or equal to x lesser than or equal to 5. Therefore, x belongs to closed interval 1 comma 5 is what the domain of this function, right? X belongs to closed interval 1 to 5 is what the domain of this particular function. Now we have this function, very nice one. Find the domain of f of x equal to cos inverse of 2 minus mod x by 4 plus log of 3 minus x whole inverse. Let us take this equal to f1x and this equal to f2x, like this. Let us find domain of each function and we take the common part of it, like this. First, let us take f1x, that is what we have here, cos inverse of 2 minus of mod x by 5. We know that minus 1 lesser than or equal to 2 minus of mod x by 4 is lesser than or equal to 1, like this. Once we have got this thing like this, if you multiply by 4 on both sides, now what we will have, minus 4 lesser than or equal to 2 minus mod x is lesser than or equal to 4. Now you just subtract 2 on both sides. Now minus 4 minus 2 lesser than or equal to minus of mod x is lesser than or equal to Okay, 4 minus 2. Now this is minus 6 lesser than or equal to minus mod x lesser than or equal to 2. Now just multiply by minus sign, that is 6 greater than or equal to mod x greater than or equal to minus 2, like this. That means mod x is lesser than or equal to 6, comma, mod x is greater than or equal to minus 2. Greater than or equal to minus 2 means what? Greater than or equal to 0, of course, right? Because mod x is always positive, greater than or equal to minus 2 means greater than or equal to 0. This is what we have here. When the mod x is lesser than or equal to 6, x belongs to, right, minus 6 to 6, closed interval. This union mod x is greater than or equal to 0 means 0, right? You are going to mod x for any value if you take, of course. So x will become any real number, I can say like this here, of course, from minus infinity to plus infinity, like this. Because mod x for any real number, it will be greater than or equal to 0, like this. And the second one we have f2x, that is 1 by log 3 minus x, like this. 1 by log 3 minus x. This is what we here 1 by 0. It should not be 0. That means 3 minus x should not be equal to 1 actually. That means 3 minus x equal to 1 means x equal to 3 minus 1, that is 2. X should not equal to 2 here. One basic thing. Because if you x is 2, log 3 minus 2, that become log 1, 1 by log 0, that become undefined. Therefore, x is not equal to 2 here. And also 3 minus x is greater than 0, like this. That means, you know that 3 should be greater than x. That means x is less than 3. X less than 3 and x is not equal to 2. That means minus infinity to 2 union 2 to 3, like this. We have in this is set 2, like this is set 1. We have like this. Now let us take the common part of this, of course. Minus infinity to plus infinity we have here, and minus 6 to 6 here. Minus 6 to 6 we have here, and minus infinity to plus infinity, that's of course true. And we have here 2 here, and we have here 3. Therefore, this is from minus infinity to infinity means this one we have here, minus infinity to 2 we have here, like this. And minus 6 to 6 is this, minus infinity to 2, like this. Minus infinity to 2 is this, and 2 to 3 is this, of course. Now the common solution, if you take here, x belongs to minus 6 to 2 union 2 to 3. This is what the domain of this particular function. How in this beautiful way we will be getting this particular solution, right? Fine. Minus 6 comma 2 union 2 to 3. That is what the solution set of this particular problem. See here, sixth one, find the domain of f of x equal to secant inverse x of by root x into step x we are having. And domain of secant inverse of x, we told you already that in this concept, secant inverse of x, the domain becomes r minus of minus 1 to 1. This is what the domain of this. That means minus infinity to minus 1 union 1 to infinity. This is what the domain of this. And when you come to denominator, the domain root x, for root x, x should be greater than 0. That means x belongs to 0 to infinity you have here. This is number 2. And you have here step x we have here. Step x under this denominator, it should not be 0, of course. Okay. That means step x, it should not be 0. Therefore, this is nothing but r minus of, right? Step x cannot be 0. That means we are going to have r minus of, we are going to include, take out 0 comma 1, like this. 0 to 1 we are going to take out. Remaining values, it is defined like this. That means this is nothing but minus infinity to 0, right, union 1 to infinity, like this. Now let us take the common part of this. Let us take the common part of this. Now minus infinity to plus infinity we have here. we have now minus 1, 0, 1 like this. The first one is minus infinity to minus 1 like this. 1 to infinity like this. Right? These are included like this. These are included. Included means this, let us include them like this. The second one is 0 to infinity like this. Okay, this is what we have here like this. Next, the third one is nothing but minus infinity to 0, minus infinity to 0 like this. Right? And fine. 1 to infinity like this. 1 to infinity. Now the third lines, 3 lines are present only here like this. Therefore, the domain is nothing but x belongs to 1 to infinity. This is what the domain of this particular function. In this beautiful way, we will be doing this particular problem. Right? See, the 17th problem, find the domain of f of x equal to x square plus x plus 1 whole power minus 3 by 2. Here f of x equal to, we can write this is 1 by this x square plus x plus 1 into square root of x square plus x plus 1 like this. Right? We know that x square plus x plus 1 will be always positive. Y means here a value is 1, b value is 1, c value is 1 and d value b square minus 4ac. This is a quadratic expression. 1 square minus 4 into 1 into 1, that is now minus 3, that is less than 0. We know that in quadratic expressions, the sign of the quadratic expression, if d is less than 0 and a is positive, here a is 1, 1 is positive, here 1 is positive. Then if d is less than 0 means the sign of this quadratic expression is same as the sign of a. A is positive, therefore this will be always positive. This is positive for any value of x, for all x belongs to R. This is positive and this is positive, therefore that is what required here. Of course, this is positive and it is defined and this is also defined, therefore the domain is nothing but x belongs to R. That means x belongs to minus infinity to infinity is what the domain of this particular function. Now see, we have here 18th one, find the domain of f of x equal to 1 by step x minus x. This step x minus x, okay, should not be 0. Where it becomes 0, that we have to eliminate from set of all real numbers. Step x minus x becomes 0 when x is an integer. Suppose you take x is 5. Now step of 5 minus 5, this becomes 0. Step of 6 minus 6, this becomes 0. Step of 8 minus 8, this becomes 0. Step of minus 7 minus of minus 7, this is minus 7 plus 7, this is 0. Therefore, this is nothing but for all integers it is not defined, because if denominator is 0, this become undefined. Therefore, the domain is nothing but R minus of okay, set of all integers, like integers is one set, R minus I is what? The domain of this particular function, right? Now we have this particular problem, f of x equal to this. Now we can write this as 1 by x power x cube, x square minus 1 plus 1 if you write x square minus 1 like this. This is now 1 by x cube plus 1 into x square minus 1 like this, right? This will be actually, x should not be equal to minus 1 actually. This denominator should not be 0. Where it becomes 0, those things we have to eliminate from set of all real numbers. X cube plus 1 equal to 0 means x is equal to minus 1. This should not be included. And x square minus 1 equal to 0 means x is equal to plus or minus 1. You know that. Therefore, the domain is nothing but R minus of minus 1 comma 1. If you take, then this function is perfectly defined, right? See this problem, the last problem of this class. F of x is equal to this. Then find f circle f of x. That means, my dear students, here f circle f of x is nothing but f of x. This is the way how it will be defined. F of x. Now this is equal to f of f of x. That means wherever x is there, you have to replace by f of x. That means 3 minus f of x whole power 7 whole power 1 by 7 like this. Now 3 minus, what is f of x? Once again we write that. 3 minus x power 7 whole power 1 by 7 whole power 7 whole power 1 by 7. This 7 will be cancelled. Now you have here 3 minus 3 plus x power 7 whole power 1 by 7. 3 minus 3 becomes 0. Now x power 7 whole power 1 by 7. This will cancel and that equal to x, right? Therefore this will become what? X, right? Fine. This is the way how you will get this. Okay, my dear students, these are the things what we have discussed today. Very, very important problems for your life. Thank you very much.